Hi guys, welcome to the map skills on section 6. So first of the map skills here, it's the ability to work out the cardiac output, which is represented by the formula of heart rate multiplied by the stroke volume. Heart rate, easy to do it. So if you don't remember, please go back to section 3, look at the cardiac cycle videos. I've done lots of work on that already in that video, but just to recap, the heart rate is 60 divided by the length of the cycle, where 60 stands per second, and stroke volume is the maximum volume taking away the minimum volume. So here what is actually the cardiac output? It's the volume of blood pumped by one ventricle of the heart in 1 minute. So the units for the cardiac output will be decimeters cubed per minute. Heart rate is the number of beats per minute, hence we're doing 60 over the length of the one cycle. And the stroke volume is the volume of blood pumped out at each beat, so the highest taking away the lowest. So we will just recap on this here really quickly, looking at that past paper question. So we've got the volume of the ventricles against the time. First thing first, how to work out the stroke volume. So the stroke volume, you should draw the line here because that's the top of your graph, and over there, and do the equation. 120 minus 40, that will give you 80. So the stroke volume is 80. Another skill here is to work out the heart rate. So you need to work out the length of the one cycle. So one cycle here, it's easy to recognize from there to there. So this is 4. Can't remember what it was, 4.46 or whatever it is, and here we've got 1.2 something. So it's so the length of the one cycle will be 1.24 minus 0.48, which gives you 76 seconds. To work out then the heart rate, we do 60 over the length of that, which will give you 79 beats per minute. And then the cardiac output is the multiple process when you multiply 80, which was our stroke volume, times the heart rate, which will give you 6,320 centimeters cubed per minute. Right. Another map skill in section 6 is to look at the units when calculating the maximum frequency of impulse conduction given the refractory period of a neuron, for example. So in here, I've got the question, and we need to use the graph to estimate the time between the maximum depolarization and the start of the contraction by the muscle. Okay, so what we've got here, the maximum depolarization is that. So I've drawn the line here for the maximum depolarization because that's what shows me the potential difference across the membrane on the y-axis. And to work out then the start of the contraction by the muscle, I need to look at this line, dotted line, so the force of muscle contraction which starts at this point. So to work out the maximum, so to work out the time in between, I need to now do the easy calculation, which is 3.4 taking away 1.8, which was here, and the answer for this question is 1.6. Right. Another question using the same graph could be to use the answer from part 1I, which was 1.6, to calculate the speed of transmission along this neuron to muscle cell. And obviously, to work out the speed, we need to know the distance. So we've got already the time, which was 1.6, and the distance is 18 millimeters. So our calculation now will be distance divided by time, which gives you the answer of 11.25. But that's in seconds. Sorry, that's in milliseconds, because you can see this on the graph here. So we need to convert this into seconds. So what we need to do, multiply our answer by 1,000, because there will be 1,000 milliseconds in a second. So this is our final answer, 11,250. Right, another skill here is to you've got the figure that shows a recording of action potential produced when the frequency of stimulation was 160 per second, and at this frequency each stimulus produced one action potential. So what I've done here, I wrote down the one action potential refers to 160 seconds, and they would like you to calculate the value of t, and they want you to do it in milliseconds. So again, that skill of knowing how many milliseconds in a second. So what we need to do, 1000, because this is how many milliseconds will be in the seconds, divided by the length of this one action, the time for the one action potential, and the final answer will be 6.25 seconds. Right? So that's the max scheme. Then you could get the max for 6 or 6.3 as well. Right? So that's everything for the max skills for section 6. See you later.